Good morning, everyone. So the keynote, and most of the talks that you'll see throughout this week, the rest of this week, they're going to be about the future. They're going to be about what's coming with Kotlin. This talk is kind of a history lesson. I'm going to be telling you about how Kotlin got to where it is today and how it's improved, how it's evolved. So I'm John Pampuch. I am responsible for production languages at Google. This is the team that delivers tooling and language systems into the wide range of developers doing server development, Android development, iOS development, et cetera, at Google. I am just got here the other day. This is the day when jet lag really hits me, so I will do my best, but if I nod off, just somebody kick me or something. So, like I said, I'm going to be contrasting Java and Kotlin. And I want to be clear, I have been using Java and Kotlin for a long time. I started using Kotlin Java rather, in 1996. I started using Kotlin much more recently. But I am not an expert by any means. You're going to be hearing from experts throughout the rest of the event. This talk is not about the technical details, but more about how we got here. I don't know how exciting this talk is going to be, so we'll have to bear with me a little bit. So, the key messages here. Kotlin and Java complement each other. They work well together. They are pretty amazing as a pair. You'd probably expect this talk to be trying to sell Kotlin to you, although honestly, everybody in this room probably are big fans, and you don't need to be sold on Kotlin. Both languages are influencing each other. That's probably true of most languages. Go, Rust, TypeScript, Java, and Kotlin are all influencing each other. We're learning new things, and we're developing the languages kind of together. Most of the time, I claim that Kotlin is ahead of Java. I think its development environment for the language itself lends itself to moving quickly. And so I think that I see Kotlin being in the lead. It doesn't mean that Java doesn't move as well, though, so we'll see some of that. And in the end, though, I maintain that Java and Kotlin are good for each other, and we should appreciate that. So there are some advantages Kotlin has. It's independent of the JVM, and that means there's less delay when a feature, if we want to introduce a new feature in Kotlin, we don't have to wait for a JVM or core libraries in the JDK. It doesn't mean that Kotlin can't take advantage of the features that are coming in the JDK, but it's not dependent on them. Give me just a second here. That helps. Java, it's aligned with the JDK and VM development. That's also advantageous. You get new features showing up in the platform that Java can expose in interesting ways. I think good examples of this were when lambdas were introduced into Java. Mostly, Java's pretty self-consistent. I think this is something that is a lesson that we've learned in language development over time. But as an example, when lambdas were introduced in the JDK, they weren't just a language feature. The whole surface of the APIs in Java were refreshed to support lambdas. It's also mostly self-contained. I think that is a desirable characteristic. Kotlin is not self-contained in the sense that it is, we're targeting iOS, we're targeting web, we're targeting the JVM, and all of those things mean that the surface has to be exposing all of those things equally. So let me talk a little bit about design goals. And this is going back to the very beginning of both Kotlin and Java. Kotlin, very pragmatic. You'll see that word, I saw it show up several times in the keynote, and I think you'll see it elsewhere. I think pragmatic dominates Kotlin's design center. It's interoperable, it's object-oriented, but pragmatic is where Kotlin is about being concise, high ease of use, and definite understandability. Indirectly, the Java design goals also influence Kotlin. Simple, object-oriented, and familiar. It's robust and secure. It's also architecture neutral, and portable, but I find that it's not as flexible as Kotlin is. A lot of attention to performance, but again, this is true for Kotlin. It's interpreted, it's threaded, and dynamic. My premise is that this competition leads to better results. We get new ideas all the time. We see them in Go, in Rust, in C++, other languages. The competition between Java and Kotlin is especially accelerated, and I see faster progress, better outcomes, and quite honestly, I see a lot of excitement. I think that's the real win, is people get excited because there is this push to make things better. That's compelling. So let me give you some caveats about this talk. This talk is mostly about Java and Kotlin, meaning the programming language. There are places in the talk where I talk about the platform, about the ecosystem, but mostly this is about the language. But as I'm sure you know, the language intersects with the ecosystem in many cases. I think that's something that Java brought to the world in spades. It was very much a ecosystem-forward platform. So I do call out some of the language features, or the platform features, when they're relevant to the language. But for the most part, I'm focusing on the language. A big part of Java and Kotlin come from their ecosystems, the libraries, the tooling, etc. These are essential to being successful in this space. When you're using Kotlin on the JVM, I claim that it benefits a lot from the Java ecosystem as well, and I think that's another advantage we see with Kotlin. Some other highlights. I'm highlighting major features. The history of Java and Kotlin is, it would take weeks to try to highlight everything that changed. So I'm focused on a relatively small set over the last 12 years or so. I'm probably missing some feature that people in this room are like really excited about. It's not because I don't care. It could be I just didn't think of it, but more than anything, it just wasn't so I just can't cover everything. Every release of Java, every release of Kotlin has hundreds or thousands of less visible changes getting packaged up in the release. That, to me, is another testament to the commitments that the organizations, the OpenJDK, and the Kotlin Foundation and JetBrains and Google all commit to the evolution of the platform. It's not just about more features, it's about making the features themselves better. They're very much a focus on high quality. So Java and Kotlin tend to release capabilities, new features, in at least two phases. I have referred to all of them as either preview or generally available. That's just a notation I'm using here. I think in practice, each organization highlights them differently. Not relevant in the context of this talk. So, a brief history. I told you this is going to be a history lesson. We're going to be focused on the past, not the future. So, 2011, way back in 2011 at the JVM Language Summit, Kotlin was announced, July 22nd, 2011. One of the things that JetBrains realized at the time was starting a whole language platform from scratch was just not viable. Starting from the ground up, it would be easier, right? Because you get to make all kinds of great decisions and do things effectively. But the practical matter is that the rest of the world already has commitments on the Java ecosystem. So Kotlin and JetBrains made the right choice to say, we're going to start working within the Java ecosystem. Very much pragmatic. This was the priority for them. Kotlin already, they were talking about some minor features that I think were, again, very pragmatic. Things like not needing semicolons at the end of the line. Little things. Java, about this time, was starting to introduce a lot of interesting features. Project Coin brought in strings and switch. Yay, that was very great. The platform added invoke dynamic. That was the very first, and so far, the last new bytecode introduced in the platform. Other platform features like 64-bit pointers, compressed 64-bit pointers, huge footprint and performance win. There were concurrency utilities added into the platform at that point. And a bunch of other features. Like I said, there's no way to cover all of them. So a lot of time passes. When you're starting a language, even one that's built on top of an existing ecosystem, there's a lot of work to do. And so we didn't see a lot coming from Kotlin. It was there, it was happening. If you wanted to, you could go into the GitHub repository and see the massive set of changes that were going in. But it was not very visible. But at the same time, Java was moving kind of slowly at this time as well. Java 7 had some great language features, but it didn't really catch on very much. I actually like to look at Java from that era as being a little bit like Star Trek movies. Even numbered Star Trek movies were good. Odd numbered Star Trek movies, not so much. And I see the same thing. JDK 6, that was great. JDK 7, kind of a yawner. JDK 8, massively huge. It was dominant in a lot of places for a very long time. JDK 9, it had perhaps one of the most interesting features that was introduced in Java ever, and that's the module system. But adopting the module system was really hard. So JDK 9 really didn't take off the way we might have wanted it to. And that's about the time when the OpenJDK introduced their new release model. And this was actually a big win for the language because it allowed the language features to get introduced at a much faster pace. Previously, major releases which would be where features would be introduced, were coming out every 3 or 4 years. That meant it was, if it didn't get done in that window, it would have to wait another 3 or 4 years. So the 6-month cycle meant features could be exposed in relatively short order, and that was a huge advantage. So 2014 to 2016, again, This is about the time when Kotlin 1.0 was released. And the major feature, Kotlin works where Java works, which was good. It's impossible to describe everything, but smart casting, string templates, named arguments are just a couple that are interesting for me, and I think really high value for developers. Again, and this was about the time when Java 8 was released. The first long-term support release from the OpenJDK. Lambda expressions, yay, went in, as well as method references. Default methods and interfaces, I use this as an interview question. I like default methods and interfaces, but they were necessary in order to make the changes to support lambdas in the JDK. Type annotations, repeating annotations, great extensions to the annotation mechanism, significantly improved type inference, and method parameter reflection. Lots of platform updates as well. Let me go on. So 2017, now we start seeing rapid updates. This is both on the Java side and the Kotlin side. Kotlin 1.1 came out in March. Java 9, September 21st. Type aliases, again, another instance of pragmatism. I find this is a way of helping developers take advantage of very complex libraries, but make them simpler for their specific use case. JavaScript support went in about this time. And there were, this was when multiplats started becoming evident in this. And this is when Google announced support for Kotlin in Android. As I mentioned, modules in Java 9, a huge feature, huge change to the platform, but it really slowed adoption because it was hard. It was hard for people to really grab onto it. But it also meant a path to much smaller deployments, which I thought was high value. All right. 2018, we saw some preview features in Kotlin, contracts, some improvements in when expressions, nested classes and annotations, parameterless main. These are just little things, but they're all, again, pragmatic. Coroutines went GA at this point. To me, the coroutines themselves represent perhaps the single most significant improvement to the programming model on the JVM across all the languages that we use there. Kotlin native started becoming visible. Previews on inline class and unsigned integers. Java, local var type inference. Okay. Java 11 came out in September, and it was the second long-term support release. And there were improvements to lambdas. And don't get me wrong, there were lots of other changes in the platform, new string methods, new garbage collectors, some crypto work, lots of platform level things, but not very much on the language front. And this is what I'm trying to highlight in this talk, is that the language features are really moving fast with Kotlin. And it's easier for Kotlin to do language changes for a variety of reasons. 2019, now we're almost getting into today. We're close. There were actually no major releases of Kotlin there, but a lot of minor releases. 2019 was actually slow for both. We added preview of switch expressions, preview of pattern matching in Java 12, a second preview of switch expressions, and a preview of text blocks in Java 13. But one big change that became apparent and clear in the Java space was their releases were very predictable now. You could almost pick the date several years in advance and say, Third week of September, we're going to have a release. Third week of March, we're going to have a release. And that's held true for a long time. Again, very predictable release structure, which I think is a really good thing for Java at this point. 2020, SAM conversions for Kotlin interfaces. Why should Java have all the fun? It's just makes lambdas better. It's good. Named argument improvements. I've been a huge fan of named arguments. They're not even a new idea. I don't know. Anybody know the language called Bliss? Nobody knows. Yeah, Bliss was introduced in the 1970s by DEC, and it had named arguments, among other things. So feature's been around, but not very many languages have adopted it. Another little item that I like in this release were the trailing commas. It doesn't sound like much. Okay, so you can put a comma at the end of a line. Well, except that when you do that, when you add items to that list, either ahead or after that, you don't introduce new inadvertent changes because of the having to add the comma now. So I like this just because it makes your, the difference view when you're in GitHub or some other tooling, you don't have, spurious differences. Java, again, a few things. Switch expressions. This was one that maybe was even a Kotlin influence. Switch expressions have existed almost from the beginning with Kotlin. But again, thinking back to the old days, expressions like this were part of Bliss, again, in the 1970s. Preview record. Record, big capability. It's coming. And then in September, sealed classes and interfaces, again, in a preview form. 2021. Oh, this was a busy year. JVM record support, obviously influenced by Java. Sealed interfaces. These were introduced earlier as preview. These are now available. Clearly, there's a race here. We're seeing sealed classes and interfaces in Java. We're seeing them in Kotlin all about the same time. Inline classes, again, value classes. These are interesting because in my view, their current form is kind of a half step, and I think that's necessary, but it does give us some insight into where things will be in Kotlin when the JVM has support for more than existing inline classes. Exhaustive when statements, suspending functions. These are preview in August and released less than 6 months later. Very good capabilities. And we're getting more improvements on type inference at this point. On the Java side, we're seeing records in place. This is, again, maybe influenced by Kotlin, but I think more than likely, this is just driven by the fact that there were alternative approaches to this using annotations, things like auto value and Lombok and so forth. So I'm guessing that the Java world and the language designers realized that the need for this capability was so high that it really needed to be built into the language. Now, I think that Kotlin data classes still have an edge with things like named parameters. I think that makes them a lot more compelling and in many cases may eliminate the need for more elaborate builder patterns and things like that. And then one other aspect of Java that came along, we have the sealed classes released, preview for pattern matching in Switch coming up at this point. all, again, a progression for Java. Again, have no idea as to whether sealed classes and interfaces were connected, but there's definitely an argument for saying that they are. All right, and then 2022. At this point, a lot of people said, oh, Kotlin's slowing down. It's slowing down because this is about where K2 was really getting a lot of focus at JetBrains and at Google. And it turns out that there's still a lot of features going into Kotlin. 3 major releases, context receivers. I think we have context parameters now for the JVM. Definitively non-nullable types. Again, preview. But big features. K2 preview in June of 2022. And a set of additional items, underscore for the type arguments, builder inference, opt-in requirements, again, very closely related to contracts. And then preview for data objects, as well as open-ended ranges, which I kind of like. On Java, pattern matching for switch. That was part of a significant improvement to switch that have similar characteristics in Kotlin. We'll see if they're really the same, but they're similar. And then Java 19 in September, virtual threads, record patterns, and another preview on pattern matching for switch. 2023, a lot of preview. A lot of internal compiler work in Kotlin 1.8, another preview of K2, Kotlin WASM, second preview for data objects, and finally, in July, open-ended ranges were released. For Java, essentially everything except record patterns and pattern matching for switch were preview. So a lot of things going in, but not things that you would consider production ready. All right. And then here we are, 2024. We've got K2 this week. It's out. Smartcast improvements, multiplat improvements. Java 2022 came out in March. Again, a number of preview features or repeating preview. But with 21, we saw the introduction of virtual threads, and a lot of focus now in Java around virtual threads with structured concurrency. That will undoubtedly be very influential in the Java space. And a number of other features, string templates. Again, this is the second preview. This is catching up to where Kotlin has been from nearly the beginning. And honestly, I kind of like how the OpenJDK has approached string templates. When it finally is released, I would encourage the Kotlin world to adopt how they've approached it, because it is incredibly flexible. One of the gaps I find with string templates today is it's really hard to use with localization resources. And I think with the way it's implemented in the OpenJDK, string templates should work in that context. They also are introducing implicitly declared classes and instance main methods. Again, this looks an awful lot like what's been part of Kotlin for a very long time. And then scoped values. Looking at scope values, it looks a lot like context, what do we call them? I've lost track. But in any case, follows a pattern of things that are available in Kotlin already. So what does all this mean? I claim that Kotlin just gets features faster. It does. But Java is closing a lot of gaps. And some might argue that Kotlin's slowing down partly because it's already done a lot of things. Kotlin has much better multi-platform support. JVM, Android, iOS, web. They both have an extraordinary degree of backwards compatibility. I think this is a really high value to the capabilities of Java and Kotlin. And it is really important, and it is all about being pragmatic. Java does compile faster. I will grant that. I don't know that that's everything, but it is a big win. Kotlin has coroutines, async flow, channels, and a lot of other async facilities that I think that Java will catch up to in some form or another, but I think coroutines are going to fundamentally be better. Kotlin has DSLs. We use this a lot at Google. It's interesting because we are selective about it. I think coroutines, DSLs are kind of like operator overloading. When you use it effectively, it's great, but it is a very sharp edge. You can do things that really make life difficult as well. I also love named arguments. I've always loved them. I think they were a great idea from the very beginning. And as a general rule, I claim that Kotlin features are about being pragmatic, developer-friendly. They are abstractions that make code more compact, easier to read, and easier to write. So they always say I should end a talk by giving you an action item. So my action item for you is to take advantage of Kotlin's cool features. There's a lot of them. They're pretty amazing. So that is about everything I had. So that's the history of Kotlin and Java over the last 12 years. Right? And at the end of every talk, you're going to see a slide like this that says, vote for the talks. And like I said, Hadi wants everybody to do this so that they know whether to invite me back next year. So, all right. So a couple of people were asking if I was going to have time at the end for questions. It turns out I do. They did say I have to stop right at 11 o'clock. So we've got 12 minutes left, I think. So, and I thought I saw some mics out there. Are there any questions? No questions. Yeah. I'm sorry? I cannot speak for the OpenJDK organization, but when they approach a problem, that kind of work, they want to do it across the board. So that's going to mean at least starting with changes at the JVM and then class file format, and introducing them right there. You could do it with just class file metadata, but I think that they would take a more principled approach and say, no, we're actually going to change the structure of the class file. That's hard. It takes a very long time to do that. So are we going to see named parameters in Java? I think it's probably not a high priority for them. If there's enough pressure, people start using it a lot and taking advantage of it in Kotlin, I think they'll have to. So, but like I said, I can't guess what their plan is. Other questions?
Hey, can you hear me? Okay. Sorry, over here.
Yeah.
Yeah, over here, yeah.
Okay.
I'll stand up and make it a bit easier. A question on Project Loom and virtual threads.
Yes.
You mentioned that you thought coroutines will be fundamentally better, and I'm curious why you think that.
Because I think they are a better abstraction. Threads are still hard to understand. They're hard to follow. I think it's easier for developers to make sense out of coroutines. This is opinion, though. So we may find that virtual threads are good enough. We also, one of the things that the OpenJDK is doing is extending virtual threads with structured concurrency facilities that probably get closer to where coroutines are today. Again, this is very subjective. There's no hard measure that says one is better than the other. But I do like coroutines. Yeah. But can we get a mic? Yeah.
Thank you. I would like to hear your opinion about how Java is approaching nullability currently. They're
I'm sorry,
doing
Java
nullability.
No,
Null types, yeah. And if you think that Java would be able to have as good nullability support as Kotlin has today.
Well, I think it can. I think it's possible. What I see happening right now, and this is something Google's been involved in for several years now, is a project that is intending to use annotations and get a uniform annotation mechanism for nullability. Part of its intent was to be consistent with Kotlin so that interop would be even better and easier. Now, the OpenJDK could adopt that directly, but I think a better path for them would be to adopt it structurally, but syntactically to maybe follow more closely to what Kotlin does. But again, it's hard to change Java. It's hard to change Java in those ways. So it may be a while. I do believe in talking to the language architect in the OpenJDK that is something they're interested in. They want to see that happen. But I think it's hard. It influences everybody's code. And when you look at how Kotlin has approached it, they'll have to do something similar because it will take a very long time to get every third-party library, every component that is part of the broader Java ecosystem up to date with a nullability standard. So I would say eventually, but I don't know how soon.
Do you think we will ever see union types coming to Java or Kotlin?
That's an interesting question. I don't know. And the reason why I say that is union types as they exist in like C are...
I mean in terms of TypeScript, for example.
Yes. I got to pass on that question. I don't know the answer. I have no idea. That might be better to ask in one of the other sessions where you've got the language designers very, very available to you. All right. Any more? I'm not seeing hands, but I don't know that I can see them that well anyways. No more questions? You can ask me about my past life. Indeed. All right. Well, thanks so much for coming. I really appreciate everybody sitting through the whole thing. I dressed up as a professor here today, tennis shoes, jacket, all that. So I did my best to be the history professor. Thanks for coming and have a great rest of KotlinConf. I think it's going to be a blast. Thank you.